Hi, my name is Dave Bodie. In this course, we will look at the basics of lighting for video. The main point of this course is to get you to think about light, to think about shadows, to think about color, and to think about how to optimize the light for your camera system. It may sound odd to think about light, but you have to understand that lighting is the key factor in how an image looks. It can affect the mood, the contrast, give you a sense of the time of day or night. It can draw your focus to the important elements in a scene, and more. Before we jump into the creative elements of light, let's talk about some basics of lighting, and that starts with exposure. Exposure is the amount of light allowed to hit the image sensor of your camera while taking a photo or capturing video. In the days of film cameras, there would be some kind of mechanism that was physically in front of the film. When you took a photo, that mechanism would move and allow light to hit the film for a period of time. Then the mechanism would move back into place to block the light once again. You would literally expose the film to light. Many digital photo cameras work in a similar way, like a DSLR. In smaller digital photo cameras and almost all video cameras, there isn't a physical mechanism in front of this sensor, so the image sensor reads the image for a period of time. The difference from when the camera starts and stops reading what is happening to the sensor for an individual image is the exposure. Whether you are shooting a photo or a video, the sensor essentially does the same thing. The camera only reads the information for a brief period of time. In a photo, it reads it just once. In a video, it reads the sensor information several times a second. The amount of times per second the camera reads and records the image is the frame rate. In any given camera system, there are things that limit the amount of light that reaches the sensor. First is the camera's lens and its aperture. All lenses will block some light. That's just the nature of optics. The amount of light loss from the glass is not something we have to think about right away. We do need to consider your lens's aperture. An aperture is a hole or an opening through which light travels. Almost all lenses on modern camera systems have variable apertures, and making the aperture smaller or larger will affect the amount of light that hits the sensor. The lens aperture is usually specified as an f number. A lens typically has a set of marked f-stops that the f number can be set to. A lower number denotes a greater aperture opening, which allows more light to reach the film or image sensor. A lens that has a maximum aperture of f1.4 will let in about twice as much light as a lens that has a maximum aperture of f2.8. Similarly, setting a lens that has a maximum aperture of f1.4 to f1.8 will let in about half as much light. Aperture also controls the depth of field, which is the distance between the nearest and farthest objects that appear acceptably sharp in an image. The next part is shutter speed, sometimes called shutter angle. The shutter speed is the amount of time your image sensor is exposed to light. If you are taking a photo with a DSLR camera, you probably have a mechanical shutter. The shutter on a DSLR is something that actually sits in front of the image sensor and blocks the light, like we talked about before. If you are taking a video with a DSLR or almost all other cameras, the imager is not physically blocked by a shutter, but instead turns itself on and off to capture the light. Like aperture, shutter speed is variable and affects the amount of light captured by the sensor. The shutter speed also affects how much motion blur is in your image. A shutter speed that is half your frame rate is considered normal. For example, if you are shooting in 24p, which is 23.976 frames a second, a shutter speed of 1/50th or 1/48th of a second would look very natural. Increasing the shutter speed to 1/100th of a second, for example, would result in an image that has less motion blur, but is also darker because the sensor has less time to expose the image. The last thing in a camera system that affects exposure is the sensor itself. You can think about this like the volume on your stereo, but in a camera system, it's called gain or ISO. All image sensors have a range of sensitivities they can be set to in order to properly expose the image. Just like your stereo, the more you turn it up, the more noise is introduced into the audio. The more your sensor is turned up, the more noise is added to the image, and somewhat decreases the detail and dynamic range. So let's review. The three things that affect exposure are aperture, shutter speed, and the image gain or sensitivity. Altering any one of those will not only change the exposure, but also change how the picture looks to some degree. So why is this important? It's important because you're not lighting for your eyeballs. You're lighting for your camera system. Lighting for how your eyes see is sort of like theater lighting. If you light a scene in theater, you light for how your eyes see it. And that works because everyone's eyes work about the same. Camera systems have many variables, so you have to consider the camera's settings and exposure when you're lighting. Let's look at some examples. All right, we're going to take a look at this video here, and this is a video that I call Crap on My Desk. The settings that I'm at right now on my camera system are f2.0, a 50th of a second, and ISO of 160. So let's say we want to increase the depth of field to get more of this image in focus. So we're going to change the aperture from f2, we're going to move it down to f2.8 and then to f4. Now that's 2 full stops. So we're cutting the light in half by going from f2 to f2.8. Then we're cutting the light in half again by going from f2.8 to f4. So that's 1/4 of the original light we had before. Now, to make sure that we have the same exposure without adding more light, what we can do is increase the ISO. Now, we were at 160, so we can go up to 320, which will get us halfway there, and then we're going to double it again to 640, which will be the same exposure that we had before. So now we're going to have more of this in focus because we have stopped down the lens of our camera system, which has increased our depth of field. So let's go down even further. Let's take the aperture from f4. We're going to go down to f5.6 and then f8. That's 2 more full stops. Now we need to increase our ISO again, 2 full stops. So we need to double it and then double it again. So we are at ISO 640. So we're going to have to turn that up to 1250 and then 2500. Now you can see we have a lot more of this fan in focus, but we also have a lot more noise in the image. Now what we're going to do is we're going to reset this. We're going to be f2, 1/50th of a second, and ISO 160. Now what I want to do is increase the shutter speed to reduce some of the motion blur in our fan. So we're going to make a change to 1/100th of a second, and then 1/200th of a second. That's 1/4 of the light again. So then we need to bump the ISO up again. So we're going to go from 160 to 320 to 640. That's 2 full stops because we lost 2 full stops of light in increasing our shutter speed. Now we're going to increase the shutter speed from 1/200th of a second to 1/400th, which cuts the light in half, and then 1/800th of a second, which cuts the light in half again. So again, we need to increase the ISO 2 more stops. So we're going to go from 640 to 1250, and then from 1250 to 2500 again. All right, now we're back to 1/50th of a second, f2.0, and ISO 160. So we'll make a change to the shutter speed. We'll go from 1/50th to 100th. And now we need to change the ISO from 160 to 320. But now we want to drop our aperture down to 2.8 and maybe even to f4. But now we need to go up 2 full notches on our sensitivity. So we're going to go from 320 to 640 and then up to 1250. So this is all showing you just the relationships between shutter speed, aperture, and the image sensitivity. If we were to change any of these and we didn't want to change another parameter, so that resulted in the image being darker or possibly even lighter, we'd have to make a change to our lighting to maintain the same exposure. So if we changed our aperture from f2 down to f4, we'd have to increase our lighting output 4 times. We'd have to double it, and then from there we'd have to double it again. So that just gives you an idea of the relationship between aperture, shutter speed, and image sensitivity. This is the very basics of lighting, getting a proper exposure. Some of you may be thinking, these new camera systems have excellent ISO sensitivity with ever-decreasing noise. Well, yes, this is true. And it's definitely a lifesaver when you can't light or you don't have time to light something. But in general, noise is not a great thing. The less noise you have, the more detail you will have in your image. But there are other things to consider about lighting and exposure, like the dynamic range of your camera.